We're doing well. In this video, I'm going to kind of work through distance, but we're going to get to distance between 2 points on a plane. Ooh la la. So today in class, we talked much about distance between 2 points on a line. So let's look at distance between 2 points on a line again. Right? And so what we kind of established today was that if we have 2 points here, here's a line, and maybe that's A and that's B. And so we'll give this a number on the number line. This may be -3, and maybe that's 6. Right? What we established today was that the length of segment AB, or the distance from A to B, is the absolute value of the difference. So either -3 minus 6, which gives us the absolute value of -9, which is 9, or we could have switched the order. 6 minus -3 to give us the same 9. Right? So since we're taking the absolute value, even though subtraction is not commutative, we can still get the same answer because we're taking the absolute value. All right, so we worked through that today. Distance between 2 points on a line, we use the absolute value of their differences. Right? So what about, of course, if we have distance between 2 points on a plane? Right? So a plane, we're talking about this guy. Right? We're talking about the coordinate plane. Now let's do a quick coordinate plane review. Right? Coordinate plane has 2 axes, the x-axis and the y-axis. Right? And so this point right here is called the origin, 0, 0. And the x value goes first, the y value goes second. So if I want to find the point 5, 3, I'm going to start from the origin and move over 5. 1, 2, 3, 4, 5, and then up 3. 1, 2, 3. That's the point 5, 3. Right? Where do you think -1, 7 would be? That's correct. I'm going to go over 1 to the left, -1, and up 7. So here's -1, 7. Okay? So we have this notion of we can have points, coordinates on a plane, and they certainly have distances between them, right? So if I want to find the distance between, I don't know, these 2 points, how the heck am I going to do that? All right? Well, I can't just, like we did in the previous example, distance between 2 points on a line, I can't just take the absolute value of the difference. It's more complicated than that, right? We don't have the same horizontal or vertical line, so it's a different situation. So there is a way, however, for me to find the distance, and it comes directly from the Pythagorean theorem, right? And so we're going to talk more about the Pythagorean theorem later, but I'm sure you remember that a squared plus b squared equals c squared. And so what we essentially are able to do is create a little right triangle here, right? And then I can evaluate the lengths of the 2 non-hypotenuse sides. So this side right here, how long do you think that side is? Yep, that's right, 5. Now, one other way to find, 6, sorry, 6. One way to find that length is you have 2 points on a line now, right? So we have this point right here, which is called -1, 3. So these 2 points right here, I'm going to highlight them. Well, the distance between those 2 points, which have the same y value, they're along the same horizontal line. It's just the absolute value of -1 minus 5, right? Or you can just count. How about these 2 points here, the other 2? Right? So I have a point here and a point here. They're on the same vertical line, right? Same x values. So the distance here to here, well, you can count, sure. Or we can think of it as the absolute value of 7 minus 3, which is 4. Okay? Now, you may remember the Pythagorean theorem, which says this 4 squared plus that 6 squared equals our d squared. 4 squared plus 6 squared equals d squared. And now to solve for d, I'm going to square everything. I'm going to keep my order of operations intact. I'm going to add them. And then I'm going to take the inverse of squaring, which is square rooting. And remember, there's really a plus or minus out here. Because we're talking about distance, it's just positive, right? So now we play this game, right? We want to try to find square factors. And 52 is 4 times 13, I reckon. And now the square root of 4 comes out as 2. So we end up with 2 root 13. Okay, now that's not a nice number. It's actually an irrational number. But nonetheless, that is the length, the distance, between this point here and this point here. It's 2 root 13. Okay. Let's generalize. Try another problem. Give you a little easier one. This will come out nicely. Let's use the origin. I'm just going to do a quick messy sketch. Actually, no, I'm not. Yes, I am. And then I'll find this point up here, and I'll call that point 3, 4. Okay? So what we did in the last problem to find this distance between the 2 points on this plane, the 2 points are not on the same horizontal or vertical line. We don't have the same x or y values. So what I have to do is essentially create this triangle. Okay? And to do so, I need to use this guy, this guy. So we have these two kind of extra auxiliary lines. Right? And so I need to find the lengths of those sides, right? So the x value on this point is 3, 4, which means this x value is 3. So that makes the length from 0, 0 to really the point 3, 0, 3. Okay. To go up from 3, 0 to 3, 4, I have to go up 4 units. So that's 4. Right? Or just the difference of the y's. X value being the difference of the x's. Really the absolute value of that, y value, difference of the y's. Right? So now that's d, right? So use the Pythagorean theorem. 3 squared plus 4 squared is d squared. That's 9 plus 16 is d squared. D squared is 9 plus 16, that's 25. That makes d really plus or minus 5, but we'll just call it 5. All right, so 3, 4, 5. Okay, so to generalize, here it goes. If I have 2 points on the coordinate plane, I'm going to call the first one x1, y1. Those go together. I'm going to call the second one x2, y2. Those go together. Okay, to find this distance, I'm going to essentially use the Pythagorean theorem. And what happens is that each side of the right triangle that I can create, right, will have either a length of the difference in the x's or the difference in the y's. Okay, squared because it's quote-unquote a. So here's your a side right here. Here's your b, quote-unquote, difference of y's, and the d is your c. Right? So now when you solve for d, and we're going to get rid of the absolute value bars because we're squaring it anyway, and we can. Whoops. It's going to be the square root of all that goggledy goop. Okay, and this puppy right here, that's called our distance formula between 2 points on a plane. Okay, there's one problem I want you to think about for tomorrow. What is the distance between these 2 points, 0, 0 and 5, 12? Okay, see you tomorrow in class. Bye-bye.